Identifying ions in aqueous solutions. Chemists use mass spectrometers to help identify dissolved ions. So here we're going to just go into a little bit of theory that will help in a lab when identifying certain precipitates. So you might have two unknowns that you mix together, and using certain colors will help you determine what type of ions are actually present. So some chemists use something called a wet chemical technique to identify certain ions in solution. With each reaction, insoluble compounds precipitate out of the solution, allowing chemists to identify the ions in solution. This ion identification process is an example of what we call a qualitative analysis. So I'm going to show you guys a couple of charts. You don't have to memorize these, but just so you to see them in terms of colors that actually can appear when you're dealing with these aqueous solutions, right? So depending on the type of ion that is present, will actually give off certain colors. Sometimes they help, sometimes you got to do further tests to be able to identify some ions that might be in question, because some ions actually display similar colors. Now, intensity of color varies with concentration of the ion in solution. We talked about concentration and how mixtures can have variable composition. Right? The more solute you put in, the more that has to be dissolved. And of course, we talked about dissolving and solubility and how temperature and size all play a role in whether or not, how much of a solute actually does dissolve in solution. Now, some ions are colorless in aqueous solutions. Cations, so any of the metals that are in groups 1 and 2, okay, when they lose their electron, okay, including aluminum, zinc, and most anions are considered colorless. So if you're putting together something and you get something that's colorless, odds are you have one of these. So it's not going to be a great test to identify which one, which ion is actually present. If they're colorless, it could be any one of these. So numerous ones, right? So that's why you got to go through, let's say, other tests to be able to identify the types of ions if you're not clear, if you're not told, right? You're just given two mystery aqueous solutions that you were asked to mix together. So the color of some common ions in aqueous solutions are as follows. If we've got chromium 2 and copper 2, we get the blue color. Chromium, copper, iron, and nickel. So we've got chromium 3, copper 1, as opposed to copper 2, iron 2, and nickel 2. All of them form the color green in aqueous solutions that we'll see. Iron 3, pale yellow, cobalt 2, and manganese 2, both pink. Now, in terms of the ions, and somehow the heading got shifted here, we've got chromate, which will be yellow, dichromate, which will be orange, and permanganate, which will be purple. As I said, guys, do not memorize these. There's no need. The flame color of selected metallic ions are as such. So you can do also flame test, right? And you've seen the flame test. If you came here for open house in grade 8, where we selected certain metals, and we pretty much introduced it to the Bunsen flame Bunsen burner. Lithium will turn red. Sodium will turn yellow. Potassium violet, as well as cesium. Calcium will turn red. Strontium will turn red. Barium will turn yellowish green. Copper will turn bluish green. Boron will turn green. Lead will turn bluish white. One of the ones that we've actually burned, right? Anyone remember which one we burned in the lab? We did it also in grade 10. What was it? Magnesium. What color did that turn? White. Okay. So these are ways to help you identify the types of metals that we have in solution. And happy birthday, Priscilla.
Thank you. Ooh, I didn't even know.
So happy birthday.
Oh my god, I know. Priscilla, blow it out.
Yeah, blow it out.
I tried that before, it didn't work.
No, it didn't work. There we go.